Hyaluronic acid is a key component of human tissues that is widely and effectively used today in different therapeutic areas. Originally extracted from animal sources, the most advanced technologies allow nowadays its production by biofermentation. Starring Streptococcus equi, hyaluronic acid released in culture, hyaluronic acid during filtration purification, highly purified hyaluronic acid. Step 1. Cell bank to inoculum. The first step of the biofermentation process consists of the revitalization of the cells of a wild-type strain of Streptococcus equi, a non-hemolytic streptococcus, until their growth reaches a critical mass called inoculum. Working cell bank. A homogeneous suspension of these bacterial cells, the working cell bank has been prepared and subdivided into vials stored frozen at below -70 degrees centigrade. Cell revitalization and pre-inoculum preparation. The cells taken from one of these vials are revitalized and then cultured using a rich growth medium to obtain the pre-inoculum. Pre-inoculum. The pre-inoculum is then placed in a 2-liter vessel for transfer to the fermentation area. Inoculum preparation. The bacterial cells of the pre-inoculum are further cultured in a 300-liter fermenter to obtain the inoculum. Step 2. Fermentation and primary recovery. This represents the core of the whole process. Sodium hyaluronate molecule starts to be released and purified to remove impurities. Production fermentation. The inoculum is used to seed a rich growth medium in a 4,500-liter production fermenter. During fermentation, sodium hyaluronate is released in a soluble form into the culture medium. Filtration. The bacterial cells are removed from the cell harvest with the aid of diatomaceous earth, a highly porous substance which entraps the cells and facilitates the filtration process. Microfiltration. The resultant cell-free solution is microfiltered to remove any fine residual particles. Step 3. Purification. The filtration purification process continues until any possible impurity, contaminant is eliminated. Concentration and diafiltration by ultrafiltration. The sodium hyaluronate solution is concentrated and diafiltered by ultrafiltration to remove the majority of soluble impurities. Activated carbon treatment. Any residual soluble impurities are eliminated by absorption onto activated carbon particles. Filtration and microfiltration. The purified solution is filtered using a filter press to remove the activated carbon and then microfiltered. Step 4. Finishing and packaging. We are now ready to touch with hands the results of the whole biofermentation process, a molecule of sodium hyaluronate, highly purified with customized molecular weights, from 40 kDa to 2 million Daltons. Precipitation. The purified sodium hyaluronate solution is transferred to the precipitation vessel, neutralized with hydrochloric acid, and then precipitated by adding ethanol. Vacuum drying. The resultant precipitated product is filtered to remove excess solvent and then dried under vacuum to obtain a fine, free-flowing powder. Packaging. The purified dry powder product is sampled for quality control testing, packaged under controlled conditions, and labeled as sodium hyaluronate.